Hi, this is Ken, and we are continuing with our discussion of the probability of getting a full house. So first thing is we outlined with a tree diagram all the possible ways that one might get a full house, all the possible favorable outcomes that would give us that result. And now we're going to attach probabilities to each of the branches. First of all, we see that the chance of drawing a first card is 52 out of 52, right? I have 52 choices out of 52 cards of my first card. So there's a 100% chance there. We don't really need to worry too much about that. But as we continue on, since we're not replacing, the number of choices diminish. So on this branch we have 51, and on that branch we have 3 of those cards left in the deck. If this first card was a queen, we'd have 3 queens left, so our chances would be 3 out of 51 of drawing another queen. Then they would be 2 out of 50. If we drew a fourth queen, well, that wouldn't give us a full house, so necessarily now we only have one choice that's favorable. We have to draw a second card. And every card in the deck, any of those cards, can be the second card, except for another one of these guys. So every card except for one, because there's only one of the first card left in there. And so out of the 49 cards remaining, 48 of those choices are favorable. So we have 48 out of 49 there. And then having used up one of these, we have 3 out of 48 of those cards left. So we see our probability here is 52 out of 52. I don't know that we really need to write that, but I will all the same. Times 3 out of 51 times 2 out of 50 times 48 out of 49 times 3 out of 48. And that will give us 3 of those cards in a row and then 2 of the other kind. The next route would be this one right here. And we see we've drawn 2 of those cards. And now what are our chances of drawing a different card? Well, if 2 out of 50 is this, then there are 48 other cards in the deck. And any one of those will do. Right here, we've already drawn 2 face cards. Or 2 of F's. They're not face cards necessarily, but 2 cards. And there is 1 remaining. Or 2 more remaining, so it's going to be 2 out of 49. And let me pause. And continuing in the same fashion, we have, let's see, we've used up one of those, so there's 3 of those left. Oh, 3 out of 48. Next row down, we've used up one of those, so there's 3 out of 49 left of those. We've used up 2 of those, so on this F, there's 2 out of 48 left. On this S, we've used 3, so now there's 2 out of 48 of those left as well. And you just continue down doing the analysis. What I want you to notice here is as we go through each chain and we multiply the probabilities, this time we get 52 out of 52 times 3 out of 51. The first 2 parts match because we're going down the same branches, but then after that it changes. So it's 48 out of 50 times 2 out of 49 times 3 out of 48. Down here, the first parts match again, and they actually match a little further because they agree for most of their trip here. And then we get 3 out of 49 and then 2 out of 48. This outcome is F, F, S, F, S, and this one is a F, F, S, S, F. But regardless of which road I take, I want you to notice I always end up in the denominator 52 times 51 times 50 times 49 times 48. Always. And in the numerator, I always end up with a 52 a 3, a 2, a 48, and a 3. 52, a 3, a 48, a 2, and a 3. See, there's always a 52 and a 48, two threes, and a 2. And that'll be the case even as we keep going down um, all the way down here. We have 52 out of 52 times 3 out of 51 times 48 out of 50. I'm sorry, that looks like a 98, but it's a 4 times, what's next? 3 out of 49, and then 2 out of 48. And this one is a F, S, F, F, S, S, S. And you notice that these guys match exactly because two of the first card, two of the second card, and then the last choice of first or second is equal because you have equal number of chances of picking the first or the second card. And this is basically how you do the tree diagram. You just break it down. When you get to the bottom, you'll have basically 10 of these repetitions of whatever this is here. So your probability when you add all these possible outcomes together that are favorable will be 10 times 52 over 52, which is 1, we know, times 3 out of 51, times 48 out of 50, times 3 out of 49, times 2 out of 48. So you have 10 of those. They'll differ in order, but the outcomes will all be the same. We'll have a full house for any one of these outcomes, and the probabilities will be these numbers multiplied, but we'll have 10 of them, so times 10. And that is how you get the answer that was in the book, which was 6 out of 4,165. And that is not reducible further because this only has factors of 3 and 2, and this is a multiple of 5, and it's neither divisible by 3 or 2. Okay, that's it. Bye.